All right, good morning. Today we're going to continue talking about triangle similarity. Specifically, we'll start off with AA triangle similarity. And the A, we hopefully remember from last semester, stands for angle. Okay, so we need a triangle to have triangle similarity. If we look at this picture, it says an architect is designing a treehouse that will have supports reaching to the top of a tree. Both the architect and the tree cast a shadow. Now, first, if we were trying to say, what could we find from this picture, okay, mathematically? One thing, if he's designing this treehouse, he might want to know is the height of the tree. So if we think about it, we are trying to find the height of this tree, okay, and then he's also, well, that's pretty much what he's trying to find. Now, it says that both of them have a shadow. So if we think about it, here's this shadow. That is something he could measure. Meanwhile, the height of our architect and his shadow, I would hope we could measure both of those things. Now, we have not talked about this in great detail, but if we know 3 of the 4 parts, we can find that 4th if they are similar. Now, since both of these would be a right triangle, the sun is somewhere, let's see, I don't have a yellow one, so the sun is somewhere up here, right? Casting a shadow down, or casting light down, forming these shadows. So both of these are going to have the same angle coming from the top, okay? So this, we don't know what it is, but whatever that dot is, it would also be the same there. So these two will have a similar, these two triangles will have to be similar because they both have that right angle and they both have a similar angle from the sun. So using that, we could calculate what the height of the tree is. Now, I'm just going to make up some numbers, but let me fill this in, say that he was 6 feet tall, and his shadow was 4 feet tall, and then we go ahead and we measure this length of the tree shadow, and if the tree was the shadow was 24 feet long, then we could find what that height of that tree was. All we would have to do is set up a proportion. Okay, so we know his is 6 over 4 equals, now I don't know what the height of the tree is, so I could put an x over 24. We could cross multiply, we'd get 4x equals 144. Let's see, did I do that right? 120, yeah, 144. And at this point, we would then divide by 4, and x is going to go into that 36 times. Or sorry, 4 would go into that 36 times. And we would know the tree was 36 feet tall. Now, obviously, if his height changes, then that would change the whole result. Okay? So anyway, this is AA similarity theorem. And if 2 angles of a triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. There are also 2 other similarity theorems we'll talk about today. SSS similarity theorem. S, stands for side. So if the 3 sides of a triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. Keep in mind, that doesn't mean they're the same. Proportional means they have that same ratio. So do you see up here we had like 4 over 6, or here 4 times 6 gave us 24. For this one, 6 times 6 gave us 36, which was what was right here. So they're proportional. The final one, if the 2 sides of a triangle are proportional to the corresponding sides of another triangle and the included angle are congruent, then the triangles are similar. Okay, so for this one, we're going to actually have to use that last example, SAS. You see how we have an angle, 24 and 24. Those are the same. So we need the sides on either side. So SAS. So EF here, 15.6. We want to know, is this going to be proportionate to what we have over here? Okay, so a couple ways we can set it up. We could do 15.6 over 13 equals, now 15.6 was longer, so we'd have to use the longer of the two, 12 over 10. Okay, that would work. Or you could also do 15.6 over 12 would equal the 13 over 10. And the reason this works is in the first example, we have the same triangle, where in the second one, we have the big and the small. As long as they are consistent, something should be true about them going both ways, both up and down and left to right. Okay. Now, either way, when we cross multiply, we'll get the same thing. So 15.6 times 10, that's going to be 156. 13 times 12, also 156. Meanwhile, on this one, 12 times 13 is also 156. So either way, it works. And if that is the case, we know they are similar. Okay, so yes, they are similar, which means now we can, once again, I'll do this in blue, set up another fraction to solve for what x is. So if I do x over 10, and x is going to be the one across from the angle that we have, across from 24. So 24 is there, across from that's a 6.5. So we'll set this equal to 6.5. Meanwhile, the 10 we know was smaller than 12, so it has to be the 13. If we cross multiply here, we'll get 13x equals 65, 6.5 times 10. Divide by that 13, and we'll get x equals 5. And we're done. All right, so take a look here, and we can try to decide, are these triangles similar? So once again, we would need to use SAS. We can see here these angles are the same, okay, y and q, and we can set up an equation or a proportion and see if it's true. So if we do 10 over 12, and that would have to be equal to 6 over 8. Now if we cross multiply, we are going to get 72 equals 80. That is not true, so not similar. Now on this next one, no angles are marked. However, right here, I don't know if you guys remember, these two angles are congruent. They have a name. They are vertical angles, which means they're congruent. Okay, so I know they will be the same. So 18 over 15, is that similar? Is that proportional to 3.6 over 3? Okay, so we cross multiply, and 3 times 18 gives us 54. Now you might not be able to do this 15 times 3.6. That is fine. Just go to desmos.com/scientific. I think that's a good one, a good calculator. It can do a lot. So we have 15 times 3.6. And we get 54 as well, so we are good. Yes, they are similar. And our reason, if you want to justify, we have a side that is proportional, the two sides that are proportional, and the included angle is congruent. Now, one thing I forgot to mention is this symbol right here, this squiggle, that means similar. Okay, we remember that this equal sign with that same squiggle meant congruent, but ours is similar, meaning they are not the exact same size, but all the angles are the same and all the sides are proportional. So let's check. You can do this, well, even though the smaller triangle has 3 sides, the bigger triangle has an X, so we can't use SSS. We have to use side angle side. So this side is 30, and right here I'll highlight. So right here I'm going to use 30 and 21 equals, now I'll switch to red, and the 30 would be the longer of those two, so we need the longer of these two included this side. Now be careful, it's not 10, it's not 30. In fact, we got to add them together. 10 plus 30 is 40 divided by, and then this other side is 28. Okay, so at this point we are going to cross multiply, and I don't expect you to do this in your head. 21 times 40 gives us 840. So that was right here. And now we're going to do 30 times 28. And we get the same thing, 840, which means that they are similar. Okay, so yes, they're similar. So now it is our time to find for x. So x is right here. So if I put x over, it doesn't matter which one you choose. If I do x over 28, that was right here and here. So now we got to do 54 has to be there because it matches up with the x. And then 21 was the smallest. That one matches up with the 28. Okay, we cross multiply. We'll get 21x equals, so then we'll do 28 times 54. And then, take that divided by that 21. So 1512, I need to do 1512 divided by 21. And we get 72. All right, just a few more. All right, if we look at this one, it says find the value of x that makes PQR similar to TUV. Now, we know in order for them to be similar, all the angles would be the same. So if all the angles are the same, P and T would be the same, they're in that first slot. Q and U would be the same, they're in the second spot, and R and V would be the same, they're in that third spot. And we only need 2 to prove it, because if we have 2 that are the same, we can automatically find that third one because all triangles add up to 180. But I need to know, I can fill in that 2x minus 30 here, and if they are similar, then all of those would add up to 180. So 40 plus 2x plus 2x minus 30, all of that would equal 180. So we combine our like terms, we'll have 4x plus 10 equals 180. We'll subtract the 10, 4x will equal 170. Divide by 4, x equals. Now, to do this, it's actually going to be a decimal for us, but that's okay. 170 divided by 4, and we get 42.5. Okay, so if x was 42.5, then this would be a similar set of triangles. All right, so that is all I have for you today. There's no assignment, but please, if you are behind, continue to stay on top of things. A few of us still haven't done 12.1 from last week. Hope you guys have a great day, and if you have questions, please reach out.